Hi guys, welcome back to my YouTube channel. Today I'm going to teach you guys how to draw shear force and bending moment diagram. From our previous lesson, we already obtained our values for shear force at A all through to shear force at B and the values for bending moment from points A to B. We're going to dive straight into drawing the shear force and bending moment diagram. The first thing we need to do is draw the simply supported beam. As you can see, I've already done that. Next, you draw dotted lines representing all the points from the simply supported beam. So you draw from point A down, point C down, point D down, point E down, and point B down. So having gotten this, then pick a point, draw a straight horizontal line, one for shear force and the other for bending moment. So you have something like this. Now I want you to look at this horizontal line like a graph sheet, whereby the horizontal line represents the origin, which is a 0 mark. So you can see this little graph thing that I've done here. We take the top to be positive and then the bottom to be negative. Now, having said all that, we'll proceed to drawing the shear force diagram now. The first value for the shear force is at support RA, which is 6.5 kilonewton. Now, from the graph, we go to mark 6.5 at point A, which is here. Having marked out this point, we draw a straight line from A to meet that point, like this. After drawing the straight line, you take a look at this question. There is no force between RA and C. The next force is acting at point C, but between the points RA and point C, there is no force acting. Therefore, the line 6.5 will remain the same until it gets to another point where a force is acting. So I'm going to draw a straight horizontal line like this. Now, when we get to point C, we have another value for shear force, which is 3.5 kilonewton. So we go to the graph here, mark a point 3.5 at point C, which is here, somewhere around this point. And then we drawing the line to 3.5 like this. So have you gotten here? The same thing when you look at C to D, there is no point acting in between. The next point is at D. So the 3.5 kilonewton remains the same till it gets to this point, till it gets to the D point. Now at this D point, we have another value, which is minus 2.5 kilonewton. We'll do the same. We go to the graph, look beneath, we have a minus 2.5 points there. You trace and you mark it at the point D. Then you join the line from this horizontal straight line that I've drawn here to D. And then it stays the same until it gets to the next point, which is point E. And then the value for shear force at E is minus 7.5 kilonewton. So I'm going to do the same, mark minus 7.5 kilonewton at point E. I'm going to draw this line. I'm going to connect the lines, so something like this, and then it stays the same until it acts at another point, and then I'm going to draw a horizontal line till the end. So you can just label the first point is 6.5, the second point at C 3.5, and you can label that part positive. Underneath, we'll label that part negative. Also label minus 2.5 kilonewton and minus 7.5 kilonewton. So this is how to draw the shear force diagram. Now, the last thing to note for shear force diagram is for a point load, we only use straight lines, not inclined lines. Inclined lines are used for UDL loads. So moving on to draw the bending moment. Now for bend moment at A and B is equal to 0, so we just mark out those points A and B as equal to 0. Now at C we have a 9.75 kilonewton. So imagine a graphical representation here. We could easily mark out the point 9.75 kilonewton at point C. So I have something like this. C 9.75. So after marking that one, we move on to the next one, which is at point D. We have a 15 kilonewton meter. which is a lot higher than 9.75. So I'm going to place that mark right here. The next is at point E, which is 11.25 kilonewton meter. I'm also going to place that here. And now we join the points by inclined lines. So I'm just going to use a ruler to join all of the points. So from A to C to D to E and then B. So this is a positive moment. Also note that when drawing bending moment diagram, for point load we used inclined lines, and then for UDL we use curves. Lastly, to mark our maximum bending moment point, it is the point where shear force is equal to 0. Now if you look at the shear force diagram, this point where it crosses from the positive side to the negative side, at the point where it touches the horizontal line, that point it tends to be 0. When we trace that point down, it marks the point where the bending moment is maximum. Also, the maximum bending moment is also known as the highest bending moment value, which is the 15 kilonewton meter value at point D. So that will be all for shear force and bending moment diagram. I hope you've learned something new today. Don't forget to like this video, share, drop your comments in the comment section, and subscribe to my channel. Thank you.